Hello, and welcome to this presentation, Getting Started with the ZNB3000 Dummy Load Measurements. This presentation provides a short step-by-step guide showing how to measure or characterize dummy loads using a Rohde Schwarz ZNB3000 series vector network analyzer. This presentation assumes a basic understanding of dummy loads and how they're measured. If you're unfamiliar with dummy loads, or if you'd like a brief review, you might want to watch the presentation Understanding Dummy Loads before beginning this presentation. Let's briefly review dummy loads and how they're measured. A dummy load is a special type of RF termination that's designed to dissipate large amounts of RF power. By large, we mean powers of more than about plus 30 dBm or 1 watt. The power handling capability of dummy loads varies, and these loads are rated for continuous use and/or for intermittent use, that is, X watts for Y minutes. Ideally, a dummy load is purely resistive and presents a near perfect impedance match over a wide frequency range. Since they're one-port devices, dummy loads are quantified using one-port or S11 measurements. The measuring instrument delivers power to the load, and this is compared to the amount of power reflected or returned by the load. Results are displayed as a function of frequency in terms of voltage standing wave ratio or return loss. In the remainder of this presentation, we'll show step by step how to measure dummy loads with the ZNB3000. As with most VNA measurements, the first step is performing an appropriate calibration on the port where the dummy load will be connected. In the interest of time, we won't be covering calibration in this presentation. After calibration is complete, the dummy load should be connected. Note that in the following examples, the dummy load will be connected to port 1. Dummy loads are quantified using standard S-parameter measurements. These don't require any special license, option, or application on a ZNB3000. Once configuration is complete, the measurement will run automatically and continuously, with results updated on screen with each sweep. The first step is choosing S11 as the measurement type. This is done by going to Trace Measurement S Parameters and then choosing S11. We also need to configure the frequency range over which the dummy load will be measured. This is done under the Stimulus menu. Frequencies on the ZNB3000 can be entered in two ways, either as start and stop frequencies or as a center frequency and span. Note that start and stop frequencies of 500 MHz and 2.5 GHz are the same as a center frequency of 1.5 GHz and a span of 2 GHz. Several other parameters can be configured when making S11 measurements. Under the Power Bandwidth Average button, the generator or source power can be changed. This same menu provides access to the IF bandwidth setting, which defines the width of the filter used to measure power at each sweep point. Lowering this value will reduce noise, but will also increase sweep time. And the number of sweep points can also be changed. This is the number of discrete measurement points within the defined frequency range. Note, however, that in most cases, these parameters can be left at their default values when making measurements of dummy loads. To select how results are displayed, choose Trace and then Format. For dummy loads, the S11 measurement results are most often shown as either dB magnitude, which displays the amount of return loss, or as standing wave ratio. Most dummy loads are specified in terms of SWR, and this is the result format that we'll use in the remainder of this presentation. Markers are a convenient way to analyze traces and obtain numeric results, and these can be accessed via Trace Marker. Up to 10 markers can be placed, and the numeric value for each marker is also shown on the screen. In addition to manually placing markers, two special marker functions, Marker Search and Target Search, can also be used to place markers on specific values, such as on the trace max or min, or on user-defined values. For example, target search can be used to place markers on specified measured or y-axis values. A target value is entered, and the value can be searched left, right, or across the entire measurement trace. Another useful analysis feature is limit lines, which check for values which exceed a threshold within a given frequency range. This function is enabled under Trace Line. The threshold values are entered in the Define Limit Line dialog, and this can be a single value, or it can be broken up into multiple segments, as shown here. If the limit check switch is enabled, a message will be displayed on the limit violation, and violating segments of the trace will be displayed in a different color. Let's compare two dummy loads, both of which have a specified SWR of less than 1.1 over the range of 1 MHz to 500 MHz. We configure a limit line at 1.1 and see that the first of our dummy loads remains below this limit over the entire frequency range. The other load, however, exceeds this limit, and therefore the ZNB3000 not only displays a fail message, but also changes the color of the trace segments which lie above the limit line. Let's end with a brief summary. Dummy loads are RF terminations that can dissipate larger amounts of RF power, and are commonly used for two-way radio and broadcast applications. The two most important characteristics of a dummy load are its power handling ability and its impedance as a function of frequency. The latter of these can be measured using a vector network analyzer. On the ZNB3000, the impedance of a dummy load can be quantified using standard S11 or reflection measurements. This measurement requires configuration of the frequency range and optionally parameters such as power, IF bandwidth, number of sweep points, etc. Results are normally plotted either as SWR or as return loss, and analysis functions such as markers and limit lines can be helpful for verifying if a dummy load conforms to its specifications. This concludes our presentation, getting started with the ZNB3000 dummy load measurements. If you'd like to learn more about dummy loads, other network analyzer applications, or network analyzers from Rohde Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.